Now listing down the components of this project, firstly we have Raspberry Pi. The Raspberry Pi 4 is used in this project. It includes a 1.4 GHz 64-bit quad-core processor which helps it to support different programming languages and behave like a small computer. The Arduino Uno is a microcontroller board based on Atmega 328P. It has 14 digital input-output pins, of which 6 can be used as PWM outputs. The ultrasonic sensor emits an ultrasound at 40,000 Hz. The module has 4 pins: ground, VCC, trig and echo. The motor driver used here is L298N module, and it has a high motor driver module for driving DC and stepper motors and is used to gain control of speed and direction of the DC motors. The DC motor is an electrical device which is used to control the electrical energy into mechanical energy. It does so with the help of magnetic fields. The servo motors are the type of motors providing precise control of angular and linear positions, velocity and acceleration. The lithium powered battery is used to provide power to all the components of the system, and the jumper wire, resistors and LEDs are used for the connections of the project.
The robot consists of two bins, non-biodegradable bin on the left side and biodegradable bin on the right side. The motors are placed at the bottom of the board on the left side and another one on the right side. These motors are used to traverse the board. When both of these motors rotate in the same direction, the board moves either forward or backward. And when these motors rotate in different directions, then the board rotates left or right accordingly. Above here is a third motor which is connected to a L298 motor driver, which takes instruction from the Raspberry Pi and rotates the motor clockwise or anti-clockwise accordingly. This motor driver is powered by a 9-volt battery which is placed on the right side. Below the third motor, an ultrasonic sensor is placed which helps to detect if there is any garbage at the staging area. When the reading of ultrasonic sensor gets below a threshold value, it triggers the code. Behind there is a webcam used to capture the photo of the garbage as well as used for object detection. A circuit is hidden below the staging area, and there is a Raspberry Pi and all connections going to the sensors, drivers and motors. Camera is connected to the Raspberry Pi from behind. When garbage is placed at the staging area, the ultrasonic sensor triggers the code to capture an image of the garbage and sends it to the Raspberry Pi. Raspberry Pi identifies the garbage and classifies it into biodegradable and non-biodegradable waste. Then it sends the command to the motor driver to throw the garbage in its respective bin. The motor rotates clockwise for non-biodegradable waste and anti-clockwise for biodegradable waste.
This is the robotic arm used on a robot to collect the floating garbage. In this, 4 servo motors are used. Each is a SG90 servo motor which is able to rotate 180 degrees. The robotic arm first takes hold of the garbage using the front claws and then raises it up to a height to draw the garbage from the water body. The claw shifts back to have the proper hold of the floating garbage. This robotic arm is able to rotate 90 degrees each side. It rotates and drops the garbage on the segregation platform for further segregation. Arduino Uno is used to code the robotic arm using Arduino IDE.
Once the garbage is placed on the staging station, its presence is detected by the ultrasonic sensor, which triggers the camera to take a picture of the garbage and sends it to the Raspberry Pi. As you can see, the Raspberry Pi terminal on the screen, it classifies the garbage into paper and triggers the motor to throw the garbage into the biodegradable waste. After then, it also shows the live location of the boat on the screen. In case of non-biodegradable waste, it throws the garbage to the left side where the non-biodegradable waste bin is.
For garbage detection system, we have used YOLO model which is being executed on the Raspberry Pi. It takes input as a video stream from the camera installed on the board. The code for YOLO model is shown here, and we have imported all the libraries needed. OpenCV is being used here to process the data obtained from the camera installed on the board, and the processed data is given to the YOLO for detection. In this, we have trained the model with a dataset containing images of trash, and after training the model, we are testing the model by running. Here we are running the Python code for our YOLO model. Python code will be executed on the Raspberry Pi installed on the board, and as you can see, a video stream or image is needed to execute the code, and the camera is starting here. After the camera is started, I have placed a bottle in front of the camera and it has detected it correctly. After detection, the signals are sent to motors and the boat is moved towards the garbage, as you will see in the video right now. And after this, the robotic arm will collect the garbage.
Metal, glass, paper, trash, cardboard, plastics are in the dataset. Here we have loaded an image of a cardboard from the dataset, downloaded ResNet 50. After configuring our model, we have trained our model for 8 epochs. In this section, we will be performing predictions on the test dataset. Here, in the first image, there is an image of a glass jar which has a label of glass and is also predicted as glass. Let's just go on Google Images and find an image of Coca-Cola can for our model. We copy the address of the image, paste the link of the image here. So according to our model, it is predicted as a metal.